We're going to investigate the magnetic effect of an electric current, and we're going to look at making a solenoid. But first, let's do some review of the magnetic effect of a single wire, electric current going through a single wire. How could you detect the presence of a magnetic field? You're going to need a power supply and a wire. The wire can be anywhere on the circuit, and we can use a compass or iron filings, but how will you hold them around the wire? You can use a card with a hole in the centre, have it perpendicular to the wire, and place the magnet round and plot the field directions. And you can do it with iron filings as well. And remember the right-hand screw rule, and then we'll go on to make a solenoid. I'm looking at the lab directions here, and what are the materials we're going to use. You can pause just to read more carefully. And you'll need a core, cylindrical core, which can be made up of any number of objects. Insulated wire, but you will need to scrape the end using scissors just about 2 centimeters, 1 inch. The winding of the insulated part, wind it around the core, attach an alligator clip to the stripped ends, both ends of the core. You'll need a direct current, low current, low voltage. The wires get hot, so be careful. And here's the diagram showing the stripped ends, the core, the winding around the core of the insulated wire, attaching alligator clips to both ends, and the direction of currents determined by the power supply that we've got here, a battery or a low voltage supply. Here's a circuit diagram of the lower half. And how are we going to know that it's an electromagnet? We're going to test it with paper clips. Oh, they hang on one end or the other end. And some materials don't attract paper clips, so they weren't turned into electromagnets. And here's a diagram or photo of it, and some students actually doing the windings. Single layer,
It's like super
and
loose,
you
and
can
it's like
push them down to get the
nail.
windings closer together.
There will be no electricity going through the nail.
Oh.
Not a factor though. How are you going to test that?
We could try it again.
It takes a few minutes to produce what may become your solenoid. Attach alligator clips to the stripped ends. Don't do any of the stripped end winding around the core. Attach wires so that you can attach an ammeter and indeed the power supply, DC power supply, or regular batteries. So how are you going to test that you've actually produced an electromagnet? Got the current going through, and let's check with some paper clips.
Using long measuring current because you don't care about
The 3?
Yeah.
2.
Okay, but as soon as you get over 8,
And measuring field strength, the magnetic field strength, how many paper clips can you attach? Here's an interesting shape of them as well.
Yeah. It's quite strong.
So that's how you know that you've produced an electromagnet. And some materials here won't actually produce electromagnets, and that shows the setup quite nicely.
I can smell the burning. I smelled before,
Okay,
like, the
yeah.
inside of the bio cabinet where they have all the dead things.
Oh yeah. Can you add a third?
And again, testing the strength of the electromagnet.
As you add it. Oh, I see.
So you're determining what makes a good core for your electromagnet, and then you can do some testing as to how to affect the strength of your electromagnet. So what are you going to vary to discover more about your solenoid? So increasing the current strength may have an effect. Increasing the number of coils wound around the core, and the length of the coils that you have on your solenoid. So this is really what you're going to discover. Which of the relationships are directly proportional. And so you discover the current strength is directly proportional to the strength, magnetic strength of the solenoid. The number of coils is also directly proportional. And the length of the coils is inversely proportional. And then you can look at it mathematically: current strength I, number of coils N, length of the coils L, and come up with this formula where B is the magnetic field strength and mu is the core material. And thank you, Washington International.